John Shoch will now share with us additional computing achievements of the Alto system. During his time at Xerox PARC, John is perhaps best known for his work on Ethernet, the PUP protocol, and the first computer worm. He's currently a general partner at Alloy Ventures, which he co-founded in 1996, and is a trustee of the museum. Please join me in welcoming John to the stage.
Thank you, David. I have to keep reminding myself this is 40-year-old hardware, 40-year-old software. I'm glad my kids aren't here because all they'd say is, Dad, what's the big deal? Mac Write, Mac Paint, Mac Draw, Outlook, Java, we've seen all this before. But as I said, I'd have to explain to them the machines are twice as old as they are, and they still worked. Anyways, thank you, David. I'm not a computer historian, but in the words of those two great computer historians, Ron Popeil and Billy Mays, my job is to get up here and say, but wait, there's more. We've seen live demos of real software running. I'm going to try to cover some things which we're not going to try to demonstrate live. I'm going to talk a little bit about additional applications that took advantage of the Alto Graphical User Interface, which is its most visible manifestation and what the software shows us. But beyond that, I want to talk a little bit about things including the software development tools and, most importantly, the distributed client-server environment that was built. There are really two threads that I'd just like to reiterate that led to this demo today, one of which, of course, is some of the people who couldn't be here today, including Chuck Thacker, John Ellenby, and Bob Taylor, who we lost in the last year or two. Let me make clear, however, that Butler Lamson and Alan Kay are alive and kicking, and they unfortunately had travel and teaching obligations and couldn't join us today. And let me commend to you the excerpt from Chuck Thacker and Butler Lamson is a video that's available, if you can find it on YouTube, that was recorded in an event for the Computer History Museum. And we haven't talked very much in this presentation about the underlying hardware of the Alto. We're really focused on the software and the manifestation that people can see. But we wanted to sort of have an opportunity to bring everybody together, while we can. And that was coupled with the evolution of 3 restoration projects for the Alto that I'd like to recognize. An effort here at the Computer History Museum Software Center led by Al Casso, a group that had worked on the IBM 1401 restoration that is then working on a machine from Allen that they have up and running, and the Living Computer Museum in Seattle, which has the resources not only to restore the machine, but to keep them running. And if you were in Seattle, I commend to you the opportunity to go see these as they actually work. Let me also spend a word or two on the impact of live demos like this and other ones that have come before it in our lives. Some of you will have had the good fortune to be at some of these, the so-called mother of all demos by SRI, showing the online system, the first real system with a mouse in a huge demonstration in San Francisco. Doug Engelbart and his team had a tremendous impact on everybody. Xerox Futures Day, this is 40 years ago to the day. This was an internal demonstration in Boca Raton for Xerox management, which had a tremendous impact within the corporation as it led to efforts to commercialize this. And of these 3 that I'm mentioning, the smallest demo, but the one that perhaps had the greatest impact, was a pair of demos to Steve Jobs in 1979 at PARC. And when I think about these demos, they're important for a couple dimensions. They're forcing functions that you got to, of course, get everything to work, which is useful. They're also important because of the impact on people and events that follow from them. And they're also important because they're markers in time. Did that work get done in time for the demo in Boca? Was that before or after Steve came to see the tour? And we've seen the impact of his tour. Now, by the way, this stuff wasn't secret, and it took the live demo and the aha moment to recognize this is what you could do on a computer with the Lisa or the Mac. And by the way, if he knew where to look, he could have seen a lot of this information 2 years prior to it. In 1977, much of the stuff on Smalltalk that Dan showed was in an article in Scientific American. And if you're a real history buff and you're willing to go back to 1972, there's a great piece in Rolling Stone that I'll show you in a moment that shows the use of the mouse. And so the moral of the story is that the impact of demos that demos can have on the decisions and what people pursue. This is the Rolling Stone article from 1972. The Alto was not yet working. By the way, I may have cornered the market. I picked up 2 copies of this 40-year-old edition still around on eBay. There's one left today that I saw that's $100, but I got the 2 cheaper ones. This is Bob Taylor. This is Alan Kay. This is a cardboard mock-up of the vision of the Dynabook. This is the beanbag room at PARC. For extra credit, you can try to find me. I am in this picture. You can't read it, but these pictures were taken by the Rolling Stones photographer Annie Leibovitz. But yeah, that was really cool. And the most important thing here, this is Stuart Brand at an early system. This is pre-Alto, and I'll come back to this later. That's an SRI mouse in his hand. This is a bitmap display being driven by this rack of equipment back here, which is the research character generator. And this was in 1972, which, as I said, if you're looking for a marker, that's 7 years before the demo to Apple. As I said, I want to highlight a little more. We have seen a lot of the Alto Graphical User Interface, the most visually impactful element of it. We've seen live demos of 5 programs. I'm going to run through just a static list to give you a little more feel for the breadth of applications that were built. Now, some of these we've seen pieces of. You saw in the actual use of the machine that the standard exec was really a line-oriented interface, but Neptune was, really think of this as a proto-finder that it allowed you to list. You could select files on here for copying or deletion. It was a little bit of an evolutionary dead end. It's a point-and-click interface, but not a drag-and-drop interface. So you can select these things and cause it to do things on the file system. Gypsy has been mentioned a number of times, a superb piece of work by Larry Tesler, who I think is here, and Tim Mott, who I don't think could join us. Again, built on the underpinnings of Bravo, but it also had a layout capability and was really driven by the needs of the publishing industry and brought us the modeless editing, which, and of course, those of you who know Larry, his license plate for many years was no modes. Sorry, Larry. SIL was a simple Illustrator. This is another graphics program that was written by Chuck Thacker. It really only had horizontal and vertical lines and little templates and icons. Now, these happen to be integrated circuits. And the reason this was important is it was really the first step in a computer-aided engineering system that allowed you to feed this into a series of applications which would produce net lists and other things that were required in order to actually produce hardware from the design system. Now, we've seen the bitmap fonts that were required, and if you're going to do WYSIWYG editing in Bravo, you need to have some fonts, and this is an incredibly challenging problem. This is sort of a nominal font design system, but you need a bunch of software to go with it. It's got a display, it's got a camera, so you can look at some images, and an Alto. So some of the software that's required here, this is a system that was called Fred, also built by Patrick. Here we're seeing an image of the merger of a video image of a character that you're then trying to outline with the splines, similar to what you saw in Bob's demo. You can take those and you get an outline, and this is important because when we first started, you had bitmap fonts in a particular size and bold or italic, and it was an incredible burden to try to say, how are we going to have a family of fonts? And to get an abstract size-independent representation with a bunch of splines allowed you to then say, oh, I'm going to have a family of fonts. I can scale them. I can tilt them to make them italics, and convert these using a separate program, pre-press done by Bob Sproul, which would then allow you to turn these into the bitmap fonts that you're going to need either for the display at a coarser resolution or for the printers at a higher resolution. Icarus, we saw a little bit about this earlier, was an integrated circuit design program for laying out ICs. This is an image from a paper from approximately 40 years ago. And courtesy of Dick Lyon, this is an Icarus design from a month ago using the same software on an Alto, which I'm told is a ring oscillator, but I'm a software guy, I wouldn't know. And finally, not second to last, of course you have to have a game. This is an early game, which is pinball. This is the ball moving through here with a little bit of a ghost behind it. Flippers down here. This was done by some guys in microcode with a physics engine to make it all work. And finally, back on the more official side, some of the work that was done on document preparation systems known as the Japanese document system and the Japanese office information system. This is a screenshot, again, showing regular text combined with Japanese text, and we'll see how this gets printed a little later. So that was, again, a flyover of 8 static one slide, and let me apologize now to all of my friends in the room whose work I didn't happen to pick, and if I got the attributions wrong, all I can do is apologize and tell you I'll do better next time, if there was the next time. Now, beyond the graphical user interface is where things get really interesting, and I'm only going to be able to spend a few minutes on this. We've seen some of the applications, but the Alto and its software GUI was only a small part of this much broader contribution of system software and really a paradigm for distributed personal computing or the network. So the GUI is the tip of the iceberg, supporting the Alto hardware and its software. Of course, there was a local area network. We haven't hardly said anything about the Ethernet, which of course deserves its entire sessions on it. But even more importantly, a full network architecture, an array of network servers to support it. And if you were dazzled by all of the demonstrations, the graphical user interface, the bitmaps, and everything else, don't feel bad if you didn't see the rest of the iceberg, because you're not the only person.
At the height of Apple's early success in December 1979, Jobs, then all of 24, had a privileged invitation to visit Xerox PARC.
And they showed me really three things. But I was so blinded by the first one that I didn't even really see the other two. One of the things they showed me was object-oriented programming. They showed me that, but I didn't even see that. The other one they showed me was really a networked computer system. They had over 100 Alto computers, all networked, using email, et cetera, et cetera. I didn't even see that. I was so blinded by the first thing they showed me, which was the graphical user interface. I thought it was the best thing I'd ever seen in my life.
I don't know how to say it any better. The best thing we'd seen in our life. So let's set aside the GUI for a moment, talk a little bit about some of the other elements of system programming, object-oriented programming, and then the network environment. A few comments about the system software. The Alto, as you've seen, had microcode. It allowed it to emulate a fairly typical 16-bit mini computer of its time, a Data General Nova. Most of the software was originally written in BCPL. It's a precursor to C. If you can read C, you can read BCPL. Had a single-user OS. It had some interesting characteristics of the way the debugger worked. The disk format had enough information on the disk that if you deleted the directory, you had enough extra information on the disk that you could reconstruct the directory. I don't recommend that you do this on your PC or your Mac today. In addition to the programming for BCPL, we saw there were the bytecode emulators for Smalltalk, object-oriented integrated language and environment, which of course is what Steve was selling. When that video was done, he was at Next before he had returned to Apple. And then later Mesa, which was a strongly typed system programming language. So a lot of work in building the software infrastructure for large systems programming. But then came the problem of interconnecting all of these machines. You sort of get one machine, and as soon as you have more than one, you have to figure out what to do. We did have the Ethernet. There were some early Ethernet-specific protocols that would work on one network. The Ethernet file transfer protocol was a very simple one packet at a time. You could use it to send something to the printer. But you very quickly realize that this is not going to work when you have multiple, dozens, hundreds, thousands of machines on multiple Ethernets. And so you need what everybody knew was learning that you needed. It was an inter-network architecture. In our case, based on what was called the PARC Universal Packet, or PUP. This was developed at about the same time and in parallel with other well-known efforts, including TCP, which became TCP/IP, an INWIG effort in Europe, with the same basic underlying ideas of an abstract internet datagram with encapsulation for transfer through a particular network. But you had to go build it if you were going to make it work. And the heavy lifting on this is done. I think Ed Taft is here, and I'm not sure if Dave Boggs is. They were really the guys who carried much of the work here. And this is sort of the abstract layering. Most people have seen drawings like this before, an abstract definition of a PUP, individual network drivers down here, layers of protocols for packets, for reliable byte stream interfaces, a whole architecture that you need. The first thing, but when you start to do this, you have to start building out the actual servers that are going to be the other side of the client machines. And the first server you need is the gateway itself, what we would today call a router. So it needs the internet routing, how to move the packets around, but it's much more than that. You need the routing table maintenance, the individual that updates the routing tables, the boot server that will dispense a boot to a machine that has no disk, a name server, a time server, test server, memory testing, and others. These were all pieces of the initial gateway, again, what we'd call a router. This picture, I'm afraid, is a fake because I can't, if anybody has one, I have not been able to find a photograph of a real PUP gateway, but this is the same type of machine. It's a Data General mini computer with 2 Diablo disks in it. So it is, to the first order, the original internet router. This is a diagram of the PUP network in May of '78. So again, compared to a marker, this is a year and a half before the visit by Apple to Xerox in Palo Alto. And you'll see here each of these horizontal lines is an Ethernet. Several of them are in Palo Alto. Several of them are in Southern California. This one is in Rochester, New York. These are inter-network gateways, backbone lines, other connections, printers, and so on. This system built out a couple years later. The later version of this drawing takes about 10 pages to show all of the systems that were interconnected on the PUP network. One example within it of a particular transport mechanism that we used, we cooperated with ARPA's Bay Area Packet Radio, which was mainly being used to read your email while the truck was driving up and down the freeway. We used it as an internet link between two buildings in Palo Alto. So if you look at this half rack of equipment and you squint and you apply 30 or 40 years of Moore's Law, you get a wireless access point. Now, so you have the servers for taking care of routing and moving packets around. Of course, a really important area is printing. It was Xerox, and we weren't actually going to do away with paper. There was a series of machines that I'll talk about. The LDX was the antecedent, long-distance xerography, XGP slot years, and others. Let me just jump in here. Oop. So this is a precursor to the scanning xerographic printers. This was a machine called the LDX, the long-distance xerography. Believe it or not, these two things together are a fax machine. Each one is about the size of a refrigerator. This is a scanner. This is a printer. These were used in very specialized applications. I think some three-letter agencies used them. But this device had basically a xerographic copier in it. This is not a laser printer. This has a CRT, which is at about the extreme of the amount of light it can get. It was unbelievably slow. But if you took this half of the LDX, it was converted into an XGP, which was one of the first raster scan printers. And those of you who know Tom Malloy should ask him about his first job at Xerox and what it had to do with the XGP. You find out very quickly that the scanning CRT and a really slow engine are really not a great combination. And the right answer at that time, in an effort really championed by Gary Starkweather, was the laser printer. And it uses, in this case, this is a Xerox 7000. I'm pretty sure this is the original one. This is the Xerox 7000 engine. This was important because it had a red-sensitive photoreceptor, which was important because this is a red helium neon or Heine laser with a modulator, mirrors. There's a spinning, multifaceted mirror here, and the image dives down. You saw the schematic earlier. I have no idea what this cost at the time. This must have been a couple $100,000 perhaps to build this. Today, in a laser printer, those parts probably cost about $5. And, but if you take, that's only part of it. That's the marking engine. This is Tim Mott in a screen snap from a video. And this is the first prototype laser printer, which is ears. So this part is the slot. That's the output. This is the 7000 engine. This is that optical table up here. And hiding behind here is the rest that makes it a print server. This is where the Ethernet, the Alto, and the research character generator, which we saw in the picture with Stuart Brand earlier, turns this into a network print server of the first generation. And in addition to printing English language text, this isn't a very good picture, but it's the only one I had. You can see this is what you see is what you get in a memo from Bill English with some embedded Japanese within it. That was the first generation. This is the second generation, known as the Dover, a development effort that was led by John Ellenby, and one of these is in the museum's collection. This again has the 7000 engine. This is the paper output, but that large optical bench that was on top has been reduced into a package that fits down into the machine. And this was then shared with these were installed at a number of universities and experimental sites, and many of us printed our PhD theses on this. So the next generation of the next set of servers that one needs are file servers, places to store things. In the protocol architecture, we built a file transfer protocol on top of PUP. Multiple generations of file servers. We had a main machine, sort of like a PDP-10, but also something called the Woodstock file server, which was a page at a time, really like a remote disk. And what was supposed to be the interim file server, which lasted for a really long time. And by the way, there's a dump of an IFS that's available through the Computer History Museum that was shared by Xerox. One of the things I'll mention here is the experience with that earlier set of inter-network routing protocols, time protocols, booting, and other things, simple things at that level, and the Woodstock file server was one of the things that convinced us that you really needed this layered architecture that included packet access as well as reliable streams. What people forget is the first 3 versions of the TCP protocol, at least in the paper designs, only had a reliable stream interface. They had no packet level interface. And we weren't the only ones, but we and many others kept working with them and saying, no, you're missing what you need here, you're missing what you need here. And it was only in, as we all know, Rev 4 that the IP layer was split out from the TCP layer in the protocols, which are what we all use on the internet and the web today. Another set of services was in packet voice. Some early experiments used an A to D and D to A converter in the Alto. So the Alto was the entire compute engine. A later version, and this is led, I think some of this by Dan Swinehart, who I think is here, Larry Stewart and others, did a dedicated box, which was an ether phone that would sit between your handset, and it would integrate with the handset and the Ethernet and allow you to do voice applications over the network. It looked something like this. So that's now a scaled down computer and a phone and a speaker. And again, if you squint at that through 30 years, that becomes a SIP phone, an internet phone. But you have to squeeze it down a little bit. Some other applications and servers, this is work on worm programs. These were distributed computations that would allow you to harness machines on the network to try to do applications. And another example of network services was, of course, you have to end with games. This is a multi-machine game. This is Mazewar, which was played across different machines. It's shown here in 2 adjacent ones. We thought for the demo tonight that we might get ambitious and try to see if we couldn't hook up between here and the LCM in Seattle, and we decided that was a step too far. But it was great fun. So let me just wrap up, that the Alto itself, the hardware and software were, as Chuck said, a powerful platform for software development, GUI-based applications, but more than that, it was a piece of a broader client-server architecture, which really led to this notion of distributed personal computing. My friends here at the Computer History Museum really get frustrated with me when I try to ask the question of what was the first of something. This is always a very complicated question. And they explain to me that you need the right qualifiers and you need the right adjectives in order to really defend something. But I'm going to defer to the IEEE, which in honoring Chuck Thacker described him as the architect of the first modern personal computer, which is what I think we've really seen here today. Thank you all very much.